Hello everyone, we are now on the second worksheet of chapter 13, which is on the chi-square distribution and the goodness of fit test and the association test, which use the chi-square distributions. Now the first question in this worksheet I've already worked out on during my lecture videos, the PowerPoint lecture videos, so you may want to look it up there if you need to again. And this is actually a problem also in the book. It's been worked out in the book, so if you're referring to the book you can see how it's worked out, but I've explained this in detail in my lecture PowerPoint. All right, so you may want to go back to it if you're not sure how to work through it. Now therefore I'm going to go and start working on the second problem here, which is a new problem. All right, we haven't worked this before. Now this problem is analyzing the population by region, and it's a goodness of fit test. Now remember what the goodness of fit test does. It compares any changes in proportions from a previous year. All right, so basically it looks at the distributions of this year or a more recent year versus that in the past. That's what it tries to study. And for this particular problem, we are looking at the population by region. So it says here, according to the US Census Bureau publication, a relative frequency of the US resident population by region in 2000 was as follows. Now, remember, relative frequency means proportion. So what they've given us here is proportion. That means what proportion of the US population resided in Northeast, in the Midwest, in the South and West. Now we can always translate proportions into percentages and say that 19% of the US population lived in Northeast, 22.9% lived in Midwest, and so on. But here they've given it to us in proportion, or rather relative frequency. All right. Now a simple random sample of this year's US residents gave the following frequency distribution. So what we have in the second table is a frequency. That means observed values. So over here, frequency refers to observed values. This is actual data collected from a more recent study, which they call this year. So observed values. All right. And the first table has data which is in proportion from year 2000. And this one where we are given the observed values, that's a more recent study. All right, recent year. So question A says identify the population and the variable under consideration. So here, in the context of this problem, all right, the population would be all US residents. All US residents would represent the population. We are just studying how the population, how the residents of the country are distributed, in which part of the country they live in. So that represents the population. Now this population is not the same as the population that we are studying. This is the statistical population. All right. And then the other one says, what is the variable under consideration? It's the regions, the different regions of the country. And we are trying to see how the population or the residents are distributed. Now, part B says at the 5% significance level, do the data provide sufficient evidence to conclude that this year's resident population distribution by region has changed from the 2000 distribution? Now, the first thing is to check if all the assumptions are met, but one of the assumptions is that it says, I'm going to change the wording here. It should read like this. Are the expected frequencies greater or equal to 5? Okay. Greater or equal to 5. Okay, now the problem with this assumption is, as of now, is that it talks about the expected frequency, but expected frequencies are calculated values, and we haven't reached that point yet where we have the expected frequencies. So once we calculate the expected frequencies, we are going to come back to the assumptions and then decide if we can move further on with the problem or not. All right. Step 1 of a hypothesis test asks us to state the null and alternative hypothesis. So the null hypothesis is going to state the distribution of this year's resident population, the distribution of this year's resident population by region is the same as in 2000. All right, so null hypothesis always says that nothing has changed, everything is the same. And the alternate hypothesis states the distribution of this year's resident population has changed from that of 2000. Of this year's resident population by region has changed from that in 2000. All right. Step 2 in any hypothesis test is to determine the significance level. In this case, we are asked to use a 5% significance level. So our alpha, which is always represented as a decimal, is going to be 0.05. Now we go on to step 3, where we calculate our test statistic. And we are going to work through this table to find our chi-squared value. Keep in mind, the chi-squared formula is sigma observed minus expected whole square divided by the expected frequencies. All right. So to fill out the first 3 columns, we basically just take our data and copy them. All right. So region, our 4 regions given to us are Northeast, Midwest, South, and West, right? These are 4 regions. Just write them down. They are given. There's nothing to think about that. Just take it from the question and write it down. Then we have the next column is for the relative frequencies or the proportions, right? P for proportions. That's what it means. So that's also given to us. So just copy the proportions in the first table. So those values are 0.190. So here's no calculation going on. You should not have to think too much. Just copy the data, given data into this table. So relative frequency 0.190 for Northeast, 0.229 For Midwest, South had 0.356 and 0.225, and they must all add up to 1. Relative frequencies must always add up to 1. All right. Then the observed frequencies, that means this year's data. So again, you can go back to your question and copy everything from the second table, all the values from the second table. Those are the observed frequencies, starting with 259 for Northeast. And then we have 306, 568, and 367. All right. When you sum them up, you're going to get n equals 1500. That's our n. When you add up your frequencies, the sum of your frequencies is what the sample size is, n. All right. Now we have to do some calculations to find the expected frequencies. The formula for the expected frequencies is E equals N times P. In other words, we are applying the proportions from 2000 on our sample size to see if the same proportions were true, then what would be the expected frequency. So we are going to do N 1500 times 0.190. You're multiplying your N with 0.190. If it helps, you can just put the value 1500 for N. All right. 1500 is what N is, and then you have to apply the proportion on the 1500 to come up with the expected frequency values. So I have for the first one 285.00. How did I get that? I did 1500 times 0.190. For the next one, it's 1500 times 0.229, and I came up with a value of 343.50. Then I have 534.00. Then I have 337.50. And all these expected frequency values should also add up to 1500. All right, the sigma of the expected frequencies, because we applied the proportions on the 1500, all right, which is our n. Okay, so now we can go back. Now that we have the expected frequency values, we can go back to the first question, which was check assumptions, right? And that particular assumption was that all our expected frequencies must be greater or equal to 5. And as we note here, all our expected frequencies are way above 5, all right? So we can state all expected frequencies are greater than 5. So that's met. Greater than, oops, I'll write it here, than 5. In addition, there were two more assumptions. One was it has to be an SRS, all right? So simple random sample. So somewhere it said it's simple random sample, a simple random sample, right? So let's write that. Where are we? Here. So simple random sample, that's given, it's met. And the other one was it should be independent samples, and they are independent. You can pretty much be sure of that, because we are looking at the population distribution in the different regions, and these the samples have nothing to do with, there's no relation between the people in the Northeast versus people in the West, or people in the South, or people in the Midwest, all right? So that means it's independent. So we can go back to our table. We took a quick pause from the table to answer the first question of checking assumptions. Now it says we have to take the difference, right? Our formula has O minus E in it. So we have to go O minus E, 259 minus 285. 306 minus 343.5. 568 minus 534. So that's how we are finding the difference between O and E. So minus 26.00 for the first one. For Northeast, for Midwest, it's minus 37.50. Then we have 34 for the South and 29.50 for the West. Now, we have to go and square each of these differences. All right, so when I squared them, these are the values I got: 676.00, 1406.25, 1156.00, and 870.25. All right, so that's the squared difference. All right, it's a squared difference. Now, the final column, we have to divide these squared differences with E. All right, so that would be, so 676 divided by 285 should give us 2.371. 1406.25 divided by the expected frequency. Make sure you're dividing it with the right value, dividing it by the right value. 343.50 is 4.094. And then for the next one, I have 2.165 and then 2.579. Sum them up, which is going to be your sigma O minus E whole square divided by E. So the sum of these values are 11.201. Sum of these, all these individual chi-squared subtotals will be equal to 11.208, and that's our test statistic value, 11.208. All right, so hope it's clear now how to calculate the test statistic using a table. We just went step by step through working this formula. All right, because you cannot directly go and plug in a value of O or a value for E into this formula and get a chi-squared value, because there are 4 observed values, observed frequencies, 4 expected frequencies, there are 4 regions, right? So we have to work it through the table and then sum them up. Okay. Now we are going to use one of these approaches, critical value approach or the p-value approach. For the critical value approach, we again draw our graph diagram and show our reject and do not reject regions. So if this is what our graph looks like, then the reject region is going to be to the right. Okay, this is a right tail test. Keep in mind, if it helps, just write it out here so that you have it before you. So we have reject on the right hand side, do not reject on the left hand side, and this cutoff, the critical value, is going to be chi-squared. This is a 5% significance level, so 0.05. However, what is the DF? The DF is C minus 1. All right, what is C? C represents these 4 categories. That's what C is. All right, C represents these 4 categories. So it's going to be 4 minus 1. All right, so let me write that down here first. The DF equals 4 minus 1, which is equal to 3. So the critical value is going to be chi-squared of 0.05 with DF equals 3. Again, where did that 3 come from? Or rather, where did that 4 come from? 4 represents the number of regions, or in other words, the number of populations that we are studying, okay? Or number of categories in our study. Okay, so now we can go to the table to find chi-squared of 0.05 with df equals 3. Let me see if I have the table open. We can go straight to the table and pick it up. All right, so 3 is right here. All right, we have 3 here. And oops, I don't know what happens here. Okay, so this is 3 and we want 0.05, which is here, and this is the value we are looking for. 7.815 is our critical value. All right, go back to our table. Okay, CV is 7.815. Okay, so I'm going to write 7.815 for my critical value. 7.815. Now we are going to bring our test statistic value. So chi-squared sub 0 is 11.208. And as we see that, so this region has an area of alpha equals 0.05. And our test statistic is going to be located way to the right of 7.815, the critical value. So somewhere here, maybe, I don't know, 11.208. But you still have to write and explain, which is going to be the basis of your decision, that chi-squared of 11.208 is greater than the critical value of 7.815. It falls in the reject region, and that's why we are rejecting the null hypothesis. All right, so you have to explain why you have taken that decision. All right, the next one is the p-value approach. Now you can use your calculator or a statistical tool which will give you the exact p-value for the test statistic. Otherwise you will have to work with an estimate, but I'm going to just give you the exact p-value, and it'll be, what is the p-value? P-value is the probability of finding a test statistic assuming the null hypothesis is true. Right, so 11.208 may be located way to the right. So I'll call that 11.208. Extend the line here. And again, all chi-squared tests are right tail tests. So this is the area, all right, that we are looking for. And that will represent our p-value. However, this is chi-squared. All right, but with df equals 3. All right, same df that we used for the critical value approach, c minus 1. All right, so we are looking for area. What is the p-value? Let's define that. Area to the right, because it's a right tail test, therefore area to the right of chi-squared sub 0 equal 11.208 with df equals 3, right? And that value is, when I found that from my calculator, is 0.0106, all right? 0.0106. Now we compare P with alpha. The question we are asking in order to reject this is P less than or less or equal to alpha? So P is 0.0106. It's less than 0.05. Therefore, reject null hypothesis. Now, just make sure that both your approaches give you the same decision. So we have reject for using both approaches. So our decision is going to be reject null hypothesis. And then, of course, there is a step 6, a very important step, which is to interpret. Interpretation will say at the 5% significance level, at the 5% significance level, the data do provide sufficient evidence to conclude because we rejected it, that means the data was strong enough to reject the null hypothesis. Therefore, the data do provide sufficient evidence to conclude that this year's US resident distribution, population distribution, by region has changed, right? That's what the alternate hypothesis was saying, has changed from that in 2000. All right, so that's the complete workout of the problem. Now I quickly wanted to come back to this part of the question, part A, and correct myself a little bit. It says here, identify the population and the variable under consideration. The population is fine. All US residents represent the population under consideration. However, the variable here really is not just the regions, but the population distribution in the regions of the country, or by the regions of the country. So I'm going to correct myself and restate this, saying that it's the population distribution. Let me just erase it and rewrite. All right, it's the population distribution. Population distribution by regions in the US. That's all. I just wanted to correct it from what I had said before.